All right, hello my lovelies, SM2 students. So we are starting off chapter 9 here, right triangles, and starting off with Pythagorean Theorem. So some of this should be somewhat familiar to you. I think you've used Pythagorean Theorem before. So we're going to go through this video, fill out this notes page. You are always welcome to, you're in control here, so you can pause, try stuff, you can go back, you can slow stuff down, you can skip parts if you feel like you've got it. Just whatever works for you here. So, Pythagorean Theorem, here we go. In a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs, or c squared equal to a squared plus b squared. You're probably used to hearing it a squared plus b squared equals c squared. Same thing, works either way. The important thing to remember, though, about this is that c, so a and b, it doesn't matter. They're just the legs, whichever one you want to call which, doesn't matter. But c always has to be the hypotenuse. So c is always the hypotenuse. And if you're not sure which one the hypotenuse is, like if you don't have a picture, for example, the hypotenuse is always going to be the longest side of the right triangle. So c is always the hypotenuse or the longest side. A and b are just the other two sides. Doesn't matter which one you choose to call which. So I want you to, before you continue here, take a moment to watch this first video. In here I'll post a link, I guess, or you could click the link on your notes page probably if it's online. But this is going to talk a little bit more about the Pythagorean Theorem and just give you a bunch of kind of different proofs. It's going to talk about these Pythagorean triples that we'll get to see some of. And then this one, you could watch if you want. It's kind of interesting. It's just one of these proofs, but done like actually in real life. So you get to see them actually use it's the one with the water and the kind of turntable thing. So take, I think it's 5-6 minutes or so, watch those videos, pause this, something, and then come back. And we're going to talk about the rest of our notes here. All right, hopefully you watched those videos. If not, do it. Anyway, so Pythagorean triple is a set of 3 positive integers, a, b, and c, that satisfies the equation c squared equals a squared plus b squared. So essentially 3 whole numbers, basically, that satisfy the Pythagorean theorem. So some examples. The 4 probably most common ones you'll see are 3, 4, and 5. 5, 12, and 13, 8, 15, and 17, and 7, 24, and 25. So these are the most common ones, but any multiple of these would also be a Pythagorean triple. So if you were to multiply, say, all of those by 2, 6, 8, and 10 would be sides of a right triangle as well, or 10, 24, 26, 16, 30, 34, 14, 28, 50. So all of these would also be Pythagorean triples. Or if you were to multiply these by 3, 9, 12, 15, that's still a Pythagorean triple. So there are other higher ones than this that aren't just multiples of these original lower 4 ones. But these are the most common, and usually it's going to be these or some multiple of these. Now, you don't need to memorize the Pythagorean triples. They're not particularly important for any use. You can always find whatever you need in this with the Pythagorean theorem. It's just that if you happen to know the triples, then it might help you take some shortcuts a little bit later on. All right, so then you're going to do 1, 2, and 3, and I'm going to go through them, but I would recommend that you pause and try them on your own first, or pause, give it a shot. Or if you're super stuck, pause and watch how I set it up. Pause again, then try to go from there. So as much as you can do on your own without watching me do it, it's going to be better for you. So, number 1. Also, I'm going to do this one anyway, but if you don't have a picture, you can draw a picture. Draw a picture. Definitely do for those 2. So this one already has one, but go ahead and try those. Pause, whatever. Alrighty, so number 1. So, okay, so we're supposed to find the value of x. and decide if the sides form a Pythagorean triple. So we need to set this up. So 8, 10, x. So x is the longest one, so that's got to be c. The one by itself, it's the hypotenuse. So it's going to be 8 squared plus 10 squared equals x squared. So 8 squared would be 64, 10 squared would be 100, that's x squared. So then that's 164 equals x squared. And then, oh no, how do we undo a square? Take a square root, right? Square root, square root. So x is the square root of 164, which happens to, so it's about 12.806. So that's the value of x. Now, decide if it's the Pythagorean triple. This is not a Pythagorean triple. And we need to be a little bit careful with the triples because you may have seen the 8 and the 10 here and got, oh, sweet, 6, 8, 10. But 10 would have to be the hypotenuse. So remember, the biggest one is always the hypotenuse. So just because you have 2 of them that are part of a triple doesn't mean the other one is going to be 6. And looking at it, you should have known it's not going to be 6. But so this is not a Pythagorean triple. Also, this is not an integer. So obviously, not a Pythagorean triple. All right, number 2. So you should have drawn a picture for this one, tried it out, but if you didn't, here's a picture, and then you should try it from there. So George starts somewhere here. Sorry, my hand's kind of blocking it. Doing my best here. All right, so George starts there, and north, east, south, west. So he rides 6 kilometers south, and then he rides 8 kilometers east. And we want to know how far he is from his starting point. So we want to know how far that is. So now we can set it up then. So those would be my legs, that's my hypotenuse. So 6 squared plus 8 squared equals x squared. So that's 36 plus 64, which would be 100. Square root, square root. So x here ends up being 10 kilometers, because we had units in our problem, should have units in our answer. So 10 kilometers. This is a Pythagorean triple. Pythagorean triple. So this is where it could have saved you some time, is if you remembered or you knew offhand that 6, 8, 10 was a Pythagorean triple. If you had legs of 6 and 8, and you know the triple, you would already know that x is 10 without having to go through all this work to find it. But you can see, you find it, it works either way. All right, number 13. So Donna's TV is 19 inches long, and it doesn't really matter which way you call length here, but so Donna's got a TV here. It's kind of ugly, but whatever. So, it is 19 inches long, and its diagonal measures 25 inches. So we want to know the width of the TV. That right there. So you want to be careful here, in remembering that C, hypotenuse, is always the longest side. So this is going to be C. It's not just whatever 2 numbers you get is equal to x squared. So this is going to be x squared plus 19 squared is equal to 25 squared. So that's just still x squared. 19 squared is 361. And 25 squared is 625. So we've got a little bit extra stuff to get x by itself, but we just do that. So minus 361 on both sides. And we should end up getting x squared equals 264. So then we just take square root. And you end up getting something like 16.24807 in your calculator, but that's about 16.25, and we're dealing with inches, so that would make the most sense to round to. So the width of her TV is 16.25 inches, and that is definitely not an integer, or not a whole number, so this is not a triple, not a Pythagorean triple. All right. So then number 4. So if you haven't tried it already, pause and try it. But this is another one where this is going to be C, and we're going to have to do a lot of extra work. So we're going to have x squared plus 5 squared equals 13 squared. X squared plus 25 equals 169. Subtract 25, and you get x squared is equal to 144. Then square root, and you get x is equal to 12. So this is a Pythagorean triple. And again, if that was just you knew these really well, and you knew that 5, 12, 13 was a triple, you see here 5 something 13, you would know that that's 12 without having to go through all the work. But again, works either way. So that should be that one. All right then, on to the back here. Or converse of Pythagorean Theorem. All right, so we're going to start off with just the top part of this, and then we'll go back to the other two. But basically, Pythagorean Theorem says if you have a right triangle, then c squared is equal to a squared plus b squared, or what it said in words about the legs and the hypotenuse. So conversely, if that's true of the sides of a triangle, so if c squared is equal to a squared plus b squared, then we know the triangle is a right triangle. So we're going to come back to these two, just different cases of if it's not a right triangle, but let's take a look at this one. So you can tell, again, which one's going to be C by just looking at which one the longest side is. So we don't know that these are equal. That's what we are trying to check. So we would set up to find out if 38 squared plus 77 squared is equal to 86 squared. And so we do this, 38 squared is 1,444. 77 squared is 5,929. 86 squared is 7,396. So if we add these together, that gives us 7,373. So that is not equal to 7,396. So is it a right triangle? No. If it's not a right triangle, then it definitely can't be a Pythagorean triple. So that's not even part of this. All right, number 6 then. So you should try this on your own, by the way, first. So if you haven't, pause it, try it, then we'll check. Okay, so this is going to be C. Doesn't matter which one of these you call A, B, and C. So we're trying to find out if 7 squared plus 8 squared is equal to square root of 113 squared. So square root of 113 squared should just be 113. 7 squared is 49. 8 squared is 64. If you add 64 and 49, that is equal to 113. So because those things end up being equal, this is a right triangle. Is it a Pythagorean triple, though? Well, no, because square root of 113 is not an integer. So they're not all integers. It is not a Pythagorean triple. All right, so coming back up to talk about these other two cases. So if they're equal, then it's a right triangle. And this is part of the reason we put c squared on this side is because I think it makes these two make a little more sense. But here's the other cases you can have. So if it turns out that the longest side squared is less than the sum of the other two sides squared, then the triangle is an acute triangle. Which, if you think about it, should kind of make sense. So if they were equal, then those would be a right triangle. But if this is less, then that means one of those sides had to come down in here, which would make this angle less than 90. So if you get longest side squared less than the sum of the other two squares, then that's an acute triangle. And then go in the opposite direction. If you end up finding that c squared longest side is greater than the sum of the other two sides squared, then you have an obtuse triangle. Which again should kind of make sense if you think about it. If this is longer than what they would have been if they were equal, right triangle, that means this side would have had to come out to meet it, so that would be greater than 90 degrees, which makes it obtuse. So then you could look back at this one and decide whether or not this would be an acute or an obtuse triangle. Now, when I did it kind of backwards here, but longest side squared ends up being a little bit more than this side squared. So this is obtuse. Probably not by very much, but would be obtuse. This one we know is right. Okay, so a couple more things here then. So triangle inequality theorem. It just is one that says that the sum of sum of the lengths of any two sides of a triangle has to be greater than the length of the third side. So we can verify this. So basically, if this isn't true, you can't make your sides meet to form a triangle. So we're going to verify that 4.3 feet, 5.2 feet, and 6.1 feet are side lengths that can form a triangle. So to check that, we just add two together and make sure that it is longer than the third one. So you can check 4.3 plus 5.2, and that ends up being 9.6, which is greater than 6.1. So that side works, that way works, and then check other. So kind of, some of these are going to be pretty obvious, I think. So 4.3 plus 6.1, this is already more than 5.2, so obviously this is going to be more than the other side. That's 10.4, which is greater than 5.2. And then the obvious is that if you were to add two sides that are already bigger than 4.3, yes, that's going to be bigger than 4.3. So 5.2 plus 6.1 is 11.3, which is most definitely greater than 4.3. So it does work that you can check any sides. I would say really the only ones you need to check are to see that the two shorter sides add up to be more than the longest side, because the other ones kind of already pretty obvious there. So yes, this can form a triangle because that holds true. Now, I want you to try to figure out if this triangle is acute, right, or obtuse. So pause it and give it a try, and then we'll check. All right, so checking then. So to figure out if it's acute, right, or obtuse, basically we need to plug our values into the Pythagorean theorem and see if the longest side squared is greater than, less than, or equal to the sum of the other two sides squared. So 6.1 squared, and we want to see how that compares to 4.3 squared and added to 5.2 squared. So 6.1 squared ends up being 37.21. 4.3 squared is 18.49. 5.2 squared ends up being like 27.04. So if we add those together, that is 43.53. So 37.21 is less than 43.53. So since the longest side squared is less than the sum of the other two sides squared, this would be an acute triangle. So then on to the second page. So I would like you to try at least the first three problems on that page, 7, 8, and 9. And then if you feel like you want to try the other ones for practice and check them, great, you can do that. If not, if you feel like that's enough and you want to just get to your homework, great, do that. So pause it for a minute, try any of those you want to try, and then press play so that you can check them here. So we're trying to figure out whether this is acute, right, or obtuse, and if it's right, decide if it's a Pythagorean triple. If it's not right, it can't be a Pythagorean triple anyway. So number 7, let's check. All right, so 11, 9, 6. So remember, longest side squared, and then the other two sides squared get added together. So 11 squared would be 121, 9 squared is 81, 6 squared is 36. So we add those together, 81 and 36 ends up being 117. So the longest side squared is greater than the sum of the other two sides squared. So that would be obtuse, and it's obtuse, so it can't be a Pythagorean triple. All right, then number 8. So longest side, 41 squared, 9 squared plus 40 squared. So this one's 81. 40 squared ends up being 1600. And 41 squared ends up being 1681. So if you were to add those together, that would be 1681. So those are equal. So it is a right triangle. And Pythagorean triple, well, those are all integers. So yes, it is a Pythagorean triple. All right then, last one of these here. So this one's a little bit different because it may not be immediately clear which one of these is the longest side. So there's a few ways you could do it. One of them is just square all of them, and the longest side should be the one that gives you the biggest square. Or you could just get this one as a decimal. So if you were to divide, or excuse me, not divide, take square root 95 and multiply it by 4, you get that this is about 38.98, which is longer than the other two sides. So this would be the one that goes by itself. So 4 root 95 squared, and we want to see how that compares to 15 squared plus 36 squared. So 15 squared is 225, 36 squared is 1296. So if I add those two together, I get 1521. And if I square 4 root 95, that is 1520. So barely, this longest side squared is less than the sum of the other two sides squared. So that would be an acute triangle. Can't be a Pythagorean triple. And you can actually, I'm going to side note here, you can pretty well estimate whether or not this is going to be bigger or smaller if you just know the square root. So if you do want to try the rest, great, try the rest and you can check them. If not, this will be enough. But square root 65, I know that 8 would be square root 64, so it's probably something just a little bit more than 8. I don't know if it were square root 81, it would be 9, so it's definitely less than 9. So I know then that, and it's more than 4 because it's more than root 16. So I know this one's not going to be the longest side, that 9 is going to be the longest side. So if you're done, great, done. If not, try them, pause, and then boot it back up and check. All right. So checking then, 9. So this is the other way too, is just square all of them and see which one's bigger. So 9 squared is 81, 4 squared is 16, square root 65 squared is 65. So this one's still definitely the longest one. Oops. So 81, and then 16 plus 65 actually ends up being 81. So those two are equal, which means it's a right triangle. Is it a Pythagorean triple though? No, because square root 65 is not an integer. All right, last two then. So obviously this one is the longest side, so 37.5 squared, and we see how that compares to 36.5 squared plus 12.5 squared. So this one is 1332.25 plus 12.5 squared is 156.25. 37.5 squared is 1406.25. And then if we add those two together, we end up getting 1488.5. So this single longest side squared is less than the sum of the other two squared. So that's cute, and it can't be a Pythagorean triple because it's not right. Okay, last one then. So numbers are the lengths of the sides of a triangle. So same thing we just did up here. So we know 10 is the longest one, so 10 squared, 6 squared plus 9 squared, that's 100. That's 36 plus 81, which I know is already more than 100, but 36 plus 81 ends up being actually 117. So a single longest side squared is less than the sum of the other two sides squared, so this one would be an acute triangle. And on the back of this page there is a puzzle that you could do. I don't plan to go through that puzzle, it's just there for your practice. If enough people really wanted me to do that puzzle, I can go through some of it, but you'd have to email me and let me know. Anyway, good luck with your homework, and thank you. Goodbye.